This is Cisco training. This is Darrell. Today we're going to migrate from RIPv1 to IGRP via ships in the night routing. Now what is ships in the night routing? Well, ships in the night refers to two ships that go past each other in the night. It's nighttime, they don't see each other, and so they each go their own way without changing their course at all. In this migration, we're going to start out with RIP version 1 configured in our network, and it's going to be working. And the way we're going to migrate is we're going to turn on IGRP routing. And so our network is going to have two routing protocols, RIPv1 and IGRP. But we are not going to configure those routing protocols to interact with each other at all. The administrative distance refers to how believable the routing protocol is. We'll have two databases, our RIP database and our IGRP database. They each have candidate routes for installation in the route table. And our IGRP, if we have only a RIPv1 route, then the RIPv1 route will be injected into our route table. If we have only an IGRP route, then for a particular prefix, then only that route will be injected in our routing table. If we have the same prefix in the RIPv1 and in the IGRP databases, then the router needs to make a decision as to which route to install in the route table. And the way it does that, it can't compare the metrics, because there's no way you can compare a hop count of 3 versus an IGRP metric of 10,000. They just aren't comparable. So the way that Cisco routers decide which route to believe more is administrative distance. The lower the administrative distance, the more believable it is. And IGRP has an administrative distance of 100 by default. RIP has an administrative distance of 120 by default, so IGRP is more believable. Okay, so let's begin. Here is our network for today. Again, we're working in the 170, same network as last time. We're working as the one with 3 routers, top, middle, bottom. We're working in the 172.16 slash 16 block, classful block. We have slash 24 subnets in each location, so we don't have any variable length subnet mask problems. I've already configured my routers. RIP version 1 is working and fully operational. Let's look at the config. Show run. So let's start show start. And it says NVRAM config memory is not present. What that means is I did a write erase, I reloaded my router, it reloaded without a config, so that way I'm starting over from nowhere. I've configured my router, I have not done a write mem yet. So I should do a write memory to save the running config to the startup config. That's something that's very important to do after every configuration change in production. Since I'm working in the lab, I actually like having my routers boot up without any config. But if you're in production and you fail to do a write mem, then you haven't saved the config of your router, and guess what? If you take a power hit, your config's going to go away, and that's real bad news. That's a good way to cause a network outage, and I've seen that happen multiple times in production. So you should be doing a write mem consistently in your network. I'm not doing it very much in this training because I actually like it, but it's something I want you to always remember. Okay, so let's look at let's do a show run to look at the running config, since I'm not saving it, deliberately in my case. And it thinks for a while. Okay, so let me get all the output and then I'll scroll back to the top. Okay, so here we are at the top. The config is 586 bytes in length. It says version 12.2, meaning this config was written with a router running a 12.2 iOS version. Here are some service commands. I did not configure these. These are default. So service timestamps, whenever it prints out a timestamp for debugging, it says how long since the route, it says the uptime, or how long since the router booted. And then whenever it prints out a timestamp in the log, like if we do a show log where you can see the log, it shows how long since it booted. No service password encryption. Well, it's nice to encrypt our passwords in there, but that's so by default in iOS 12.2, password encryption is turned off. That password encryption is weak anyway. We'll talk about that in a later session. Hostname top, I configured that. IP subnet -0. This is default. I did not configure this. In our classful block 172.16.0.0/16, If we had a /24 subnet mask, then if I use the subnet 172.16.0.0/24, then I'm using the 0th subnet, because that subnet octet is 0. In old versions of iOS, you can't do that. In new versions of iOS, you can do that if you enable IP subnet -0. And in this version of iOS, IP subnet -0 is enabled by default. Cool. Moving on, our loopback interface, I've no shut it. I've got my IP address, it's a /24. Ethernet 0 I have not configured because I'm not using it in my triangle. I've got my 2 serial interfaces. I've configured my bandwidth to be 64 on one, 1000 to be another. I've configured my clock rate on the serial interface, which is DCE, Data Communications Equipment. I've got my IP addresses, no fair queue. I did not configure that. That's apparently default in this interface, but not in this interface. I have no idea why. And router RIP version 1, network 172.16.0.0. Again, this is enable or turning on the RIP routing protocol on any interfaces with IP addresses inside the classful network 172.16.0.0. Because the first bit is a 1 and the second bit is a 0, this is a /16 classful network, a class B. And then IP classless. Everything we've been doing so far is classful routing. This router actually can forward packets based on classless routing, and it enables that by default. I'm not going to talk about exactly what this command does today. IP HTTP server. Oh, here's something bad. My router by default has a web server on it, and so you can connect to the router on port 80 and configure the router. If this is in production and you don't want hackers to log into your router, you might want to turn this off by typing in no IP HTTP server. I believe this is turned off by default in more recent versions of iOS. And then for IP protocol independent multicast, bidirectional is enabled. Bidirectional multicast is enabled. We'll, maybe in about a 30th or 40th episode, we'll start talking about multicast and exactly what that means. Not today. That was enabled by default. I did not configure that. Okay, line console, line 1 to 16 for the asynchronous serial ports on this router. Line aux, line V2Y, I haven't configured anything there. These are the different ways to log into the router. And so if I wanted to log in via telnet, then I could configure a password on the line V2Y. If I wanted to block somebody from logging in via the console, I am logged in on the console right now, then I'd configure that way. The difference in behavior is on the console, by default you can log in. On the V2Y, you cannot log in until some sort of password is configured on the box. Okay, so that's my config of this router. My other 2 routers are configured similarly. If going back to my map, I'm up here on the top router. Here's this loopback, and here's this loopback, and I should be able to ping them fine. Let's test that. Ping 172.16.3.1, success. Ping 172.16.5.1, success. Show IP route. And I have, for the loopback on the middle router, which is on the left side, I've got one route to it. It is administrative distance 120. It is 1 hop count away. Hop count is my metric and RIP. For the loopback on the rightmost router, the bottom router, I've got, I should start calling these routers top, left, and right. I've got that route, I've got it via 1 path, 1 hop count, administrative distance 120 because it's RIP. And then for the subnet between the 2 other routers, I can get there via 2 paths, via the left path and the right path. Each is 1 hop count away. Now note that that's one of the limitations that shows a problem with RIP, because this path is definitely faster than this path, because this path has a clock rate of 1,000,000 and this path has a clock rate of 64,000. But RIP only talks in terms of hop count as its metric, and 1 hop equals 1 hop, so I can get there both ways. Okay, so there we are, and let's start our migration from RIP to IGRP via ships in the night routing. Conft router IGRP, and I need to give it a autonomous system ID. I'll give it 1. I should work up in the private autonomous system 65,000, but yeah, I'll do 65,000. I should be good. network 172.16.0.0 end. Now again, there's no command to look at the IGRP database. If I can show IP RIP database, here's the RIP database showing the candidate routes for the routing table. One important thing is to keep in mind that the routing table does not forward packets. I'm sorry, the RIP database, the routing protocol does not forward packets. All the routing protocol, like RIP does, is it populates the routing table. The routing table is what is used to forward packets. So this RIP database does nothing other than populate the route table. Now if I do a show IP route, now I can see that here are the routes that come from RIP. That's what the R means, and it's installed in the routing table. And this is what's used to forward packets, or Ceph might be used if I enable Ceph. Let's go ahead and do that. Conf T IP Ceph. Now if I do a show IP Ceph, and you can see now I've built my Ceph table. Use a little more memory. My processing's going a lot. I'm forwarding packets a lot faster. Show IP route. I just enabled IGRP on this router, but I'm not seeing any IGRP routes. And the reason is because I haven't enabled IGRP on any other routers. Routing protocols are, routers already know what's directly connected to them. The goal of the routing protocol, such as RIP or IGRP, is to figure out what's connected to other routers. And in order for that to have any effect, you need to enable the routing protocol on multiple routers. Okay, let's go to the middle router. Show IP route. And you see I've got my RIP table, route tables here. Conf T router IGRP 65,000 network 172.16.0.0 end. Show IP route. That was fast. And you notice now I still have one RIP route, and that's to the loopback on the bottom router, which is still only running RIP. But to the serial link on the far side, I have two paths. One via let's talk about this 172.16. This is the middle router, and for the 172.16.5.1 5.0/24 subnet, I get there via RIP, and that is because the bottom router here, this router, is only running RIP. I have not enabled IGRP on this router. On the top router and the middle router, they are both running RIP and IGRP. So to get to the 170.16.1.0/24, to get to this subnet, 172.16.1.0, I can get that data via RIP or IGRP, and I get it via IGRP. My metric is huge, 158,750, whereas my RIP metric is only 1 hop. But you can't compare metrics between different routing protocols. All you can do to compare them is use how believable the routing protocol is, and IGRP is more believable than RIP. And for this subnet here, the serial link on the far side, I can get there via RIP or IGRP via the top router, and I can get there via RIP on the bottom router. Which am I going to believe? Well, you guessed it. That's the 172.16.6.0/24 subnet, and I believe IGRP, and I do not believe RIP. Great. So now I've got RIP and IGRP here, RIP and IGRP here, and just RIP here. So let's turn off RIP on this router and see what happens. Because then we'll have two routers with IGRP and two routers with RIP. And so conf T no router RIP end. Show IP route. My routing table's shorter than it used to be. There's something missing. In fact, it's this subnet here, 172.16.5.0. I am running IGRP here. I am running RIP here. So these two routers have different routing protocols and are not talking to each other with the routing protocol over this link. Now you might think that because this router is running IGRP and it's running RIP, that it would have information on both directions, and it does, but it doesn't pass that along because there's no redistribution configured. What is route redistribution? That's where you take routes from one routing protocol and plug them into another routing protocol. We have not configured that, so it's not happening. So in effect, we have two distinct routing domains: our IGRP routing domain with the top and middle routers, and our RIP routing domain with the top and bottom routers. So from the middle router, if I ping 172.16.5.1, I can't do it because I don't have a route to get there. My router doesn't know where to send the packet. Okay, that's bad. I just made a network change and my network is partially down. There are two routers in our network that cannot talk to each other. So let's fix it. Conf t router RIP version 1 network 172.16.0.0. Back out of my change. You'll do this in production. You make a change, you screw up, you back out. Ping 172.16.5.1, and we can ping it again. Okay, well, you know, our whole goal here is to migrate from RIP to IGRP. And so now that we've enabled IGRP on top and middle router, we turned off RIP on the middle router, that didn't work. We're doing ships in the night routing. The way to complete the migration successfully is to turn on IGRP and the whole routing environment. So let's go to the bottom router. Conf t, so show IP route. And you can see I've got my RIP routes. Conf t router IGRP 65,000. Again, this is an autonomous system number, and the reason it's an autonomous system number is that the number has meaning outside of the router. The autonomous system number is actually passed in the updates. And so on another router, if you have IGRP configured but with a different autonomous system number, then they won't talk to each other. If the number only had local significance, like it does with some other routing protocols like OSPF, then it would be called a process ID. Okay, so router IGRP 65,000, network 172.16.0.0, and show IP route. Now all of my routes are either connected or IGRP. None of them are RIP, and that's because we have, on all three of our routers, we have RIP and IGRP configured. And so we still have a RIP database, so IP RIP database, show RIP, show ver. Look at my version. Oh, this is 11.3. Maybe there's no way to show the RIP database here. Let me go to another router where I have a RIP database. Yeah, okay, here's a router with a RIP database, and you can see the RIP database, and show IP route. There's entries in the RIP database, but every route is IGRP because IGRP is more believable than RIP. So that's now what we can do. Conf t no router RIP. And even after doing that, I can still ping 172.16.3.1, ping 172.16.5.1. Once I enabled IGRP on all of my routers, then and only then was I able to start disabling RIP on all of my routers. So this is a pretty simple migration. I had a relatively unbelievable protocol, RIP, with an administrative distance of 120. And I configured my new routing protocol, IGRP, which is more believable on all of my routers. And then I turned off RIP, and the migration went smooth. That's good news. And I think that concludes our lesson for today.